Welcome to Lesson 1.2, Patterns and Relations. This lesson is going to continue on the patterns in division. You're going to learn the divisibility rules for 0, 3, 6, and 9. So far, we've mastered the methods for telling if a number is divisible by 2, 4, 5, 8, and 10. So now we're just going to extend that to the other numbers. Let's start with the divisibility rule for 0. If you take your calculator and you divide a number by 0, what do you think is going to occur on your calculator? Why don't you try it? Pause this program while you go get your calculators. Okay, you should be back by now. If you take and divide your calculator by 0, let's pull up my calculator. And I take it, here, get bigger. Let's say I take 3 and divide it by 0 and press equals. It says infinity. Now this is a math-based program, so it actually tells you what the answer is. There are an infinite number of times that you could divide a number by 0. Now most calculators are going to tell you that it's an error, or you might even get a divide by 0 error. Okay? So the result you get is either an error, or depending on your calculator, divide by 0 error. Now, why do you think this is the case? Well, you have to understand what this is, you have to understand about what dividing actually is. Dividing is subtracting, but keeping track of how many times you actually subtract something. So why do I think this takes place? Well, what happens is you can make an infinite number of zeros, or an infinite number of groups, I guess, of 0. From a whole number. You can make an infinite number of groups of 0 from a whole number. So let's show you why or how this works. I'm going to take 8 and I'm going to divide it by 2. This is what your calculator is going to do. Your calculator is going to take and go 8 minus 2 is 6, and then over here it's going to keep track of how many times it did it. So that's the first thing. The second thing it's going to do is see, can I take 2 away from 6 again? So in this case, I get 4. And now, there's your second one. If you take 4 minus 2, now we're down to 2, there's your third one. And then 2 divided by 2 gives me 0, and that's the last time. Now your calculator adds all these things up and says we did this 4 times. So then it will conclude and show you on the display that 8 divided by 2 can be done, and you can get 4. But what we're doing here is making a rapid subtraction and keeping track of it. So the final result is that you can subtract 2 from 8 4 times. So 8 divided by 2 is 4. Now what happens when we divide by 0? Well, I want to try and show you a grouping method first, okay? I want you to think of 8 objects. Those are represented by the small x's. How many groups of 2 can you make out of these 8 objects? Okay, now if you take a look, you can circle them, and I've done that for you. Here's your first group, here's your second, your third, and your fourth. So we have 4 groups. So if I take 8 and I put them in groups of 2, I can have 4 groups. This is another way. This is called grouping. You can do it that way, and it'll show you that it divides it 4 times. Now, let's go back to the divide by 0 issue now. Now, if we do a subtraction like we did before and keep track of how many times we did it, look what happens. I'm going to take 8 and I'm going to subtract 0 from it. And I'm going to get, when I subtract 8 minus 0, I'm going to get 8. But over here, my calculator is going to keep track of it. Then it's going to say, can I take 0 from 8 a second time? And of course, it's going to take 0 again. And it's going to get 8. It's going to keep track of that. Then it's going to do it again. and keep track of that. And then it's going to do it again and keep track of that. So what do you notice is taking place here? Well, you should notice that the 8, when you divide by 0, never changes. It never gets less. The 8 never decreases. What this means is, when you divide 8 by 0, and you take 0 away each time, the calculator is going to keep track of it, and that's where you're going to get an infinite number of times. And the calculator we just showed you told you it's infinity. Your calculator actually, depending on the model, if it says error, what it's doing is it's taking this number of times that you subtracted 0 and it's keeping track of it until the memory of your calculator is full. And once that memory is full, the calculator will tell the main brain of your calculator, hey, I can't hold anymore. And the calculator is going to say back to the memory, but you have to, and then they're going to agree that an error has taken place. Let's take a look at the next explanation. If I have those 8 x's on the board, and I want to make groups of 0, how many groups can you make? Well, here's a group of 0, here's a group of 0, and so on. And you can see that I've got, what, 1, 2, 3, 4, 5, 6, 7, 8. I've got 9 groups of 0. But can I make more groups of 0? How long could I sit here and make groups of 0? Well, I would have to do it an infinite amount of groups. The number 8 doesn't get smaller. Because it doesn't get smaller, I'm never going to reduce these x's to have the calculator stop from dividing. So what ends up happening is you end up getting an infinite number of zeros. And this actually has a term. Okay? And this term is actually the word undefined. Okay? What it means is there's no number. You can't define how many times 8 is divided by 0. So whenever you're asked for the rule for dividing by 0, your answer is going to have to be no number is divisible by 0. I'm not expecting you to give me a whole huge explanation. Just understand that it's undefined. So now let's take a look at the divisibility rule for 3. Well, to do this, what I want you to do is, I'm going to actually just tell you what the divide rule is, and then we'll do some examples. To find if a number is divisible by 3, you add up the digits. You add up the digits in the number. Now here's the test. You take that sum and you check to see if that sum is in the 3 times tables that you know. And the way we're going to state that is, check if that sum is divisible by 3. Now, you may not understand exactly what I'm saying here, but let's do a couple of examples, and I think you'll catch on pretty quickly. The first example I'm going to do is 123,345. What you have to do is take the 1 and the 2 and the 3 and the 3 and the 4 and the 5, and you want to add them all up. So 1 and 2 is 3, 3 and 3 is 6, 6 and 3 is 9, 9 and 4 is 13, and 13 and 5 is 18. Sorry, I think I misadded. 5, 9, 10, 18. No, I think I got it right. 1, 2, 3, 3, 4, 5. Yeah. So this number, when you add it all up, gives you 18. Now, is 18 in the 3 times tables? Well, you should know from your times tables that 3 times 6 equals 18. So since you can take 18 and divide it evenly by 3, that means that 123,345 is divisible by 3. And the reason is because the sum of its digits is divisible by 3. Okay, I'll just wait a second to get that copied down. Okay, you should have that done by now. Now let's try our next example. It's 1,256,256. So I'm just going to take this, move down here, and work here. Let's take the numbers and add them up. So we have 1 plus 2 plus 5 plus 6. There you go. Now you can add them all up. Now if you take your calculator and you add them up, you're going to find that the sum of these 7 numbers, or 7 digits, is 27. Now, is 27 divisible by 3 evenly? And the answer to that is yes, because 3 times 9 is 27. So the answer to whether or not 1,256,256 is divisible by 3, the answer to that is yes, it is. And why? You put down because the sum of its digits is divisible by 3. So, to sum it all up again, how do you tell if a number is divisible by 3? You add up all the little numbers, the digits, and you find out whether that sum is in the 3 times tables or is divisible by 3. If it is, then the large number you started with is divisible by 3. If it is not, that means that the number that you're checking is not divisible by 3. So let's have you do these ones right here. 1,111,111. Give you a second to do that one. Actually, why don't you do all 3, and then pause this recording, and then I will we'll do the corrections. All right, you should be done by now. So add these all up. Well, I've got 1, 2, 3, 4, 5, 6, 7 ones, so it should be pretty easy just to do this in your head. But we'll put it down just because somebody may want to see it. So the answer to that is 7. Now, is 7 divisible by 3 evenly? If it is, then 1,111,111 is also divisible by 3. But since 7 is not divisible evenly by 3, it goes 3, 6, 9, skip 7, then we know that this number right here is not divisible by 3. So the answer to this is no. And the reason is its sum of digits is not divisible by 3. All right. Now let's try the second one. 101,101,101. Well, I've got 1, 2, 3, 4, 5. I got 6 digits there. So the sum is equal to 6. Is 6 divisible by 3 evenly? And the answer to that is yes. 3 times 2 is 6. So this number is divisible. I'm having trouble spelling divisible. By 3. And the reason is because its sum of digits is divisible evenly by 3. Okay, our last example. Let me make some shrinkage here. All right, let's just move down. Okay, so this one here, we'll move it down to here. 156. Add the numbers up. 1 plus 5 plus 6, and that's 12. So the answer here is yes, because the sum of digits is divisible evenly by 3. Okay? So now the next thing we're going to do is we're going to test your understanding. I want you to take this number right here, and you'll notice it has a question mark in it. So I've got 1, 2, blank, 695. So I have 120 something thousands, 695. I want you to tell me what number goes on this blank. Now remember, there could be more than one. I'll give you a second to try to figure it out. Pause the recording. Okay. Well, how do we figure this out? Well, we have to work with the addition. So I want to know 1 plus 2 plus what plus 6 plus 9 plus 5 is going to give me a number divisible by 3. Well, let's take a look and sum up the other one, these ones here first. 1 and 2 is 3, and 6 more is 9, and 9 is 18. So far I have 23. Well, in order to tell which numbers are divisible by 3, I have to check the multiples of 3. Well, 7 times 3 is equal to 21. 8 times 3 is equal to 24. So if I had one more digit, the number 1 in there, I'd be able to add these all up and get 24, which is 8 times 3. So one of the possibilities could be a 1. Are there any other possibilities? Well, you should have seen that. What if I added a 4? Well, 23 plus 4 is going to give me 27, and that's 3 times 9. So this could also be a 4. What about if I added 7? 23 plus 7 is going to give you 30, and that's 3 times 10. So that means this could also be a 7. So what could this unknown number be? Well, it could be a 1, a 4, or a 7. Now, the divisibility rule for 6. The divisibility rule from 6 comes from the fact that 2 times 3 equals 6. If a number is divisible by both 2 and 3, then the number is also divisible by 6. But it has to be divisible by both the 2 and the 3. So it's got to be an even number. So anytime you see an odd number, you know that that number is not going to qualify. You have to get rid of that one. And if you see it's even, then you got to check for the rule of 3. So you're going to have to remember both of these rules, the rule for 2 and the rule for 3. So it's kind of like a double test. So for 246, the first thing you're going to do is you're going to check for 2. Is 246 divisible by 2? Well, 246 ends with a 6, and that is one of the 0, 2, 4, 6, 8 numbers that you need in order to be divisible by 2. So it's an even number. The answer to this one, therefore, is a yes. So this number here, 246, has passed the first stage. Now going on to the second stage, it must also be divisible by 3. So check for 3. Well, the divisibility rule for 3 is to add 2 plus 4 plus 6 and see what we get. Well, we get 12. Is 12 divisible by 3 evenly? Well, you can take 3 and you multiply it by 4 and you can get 12. So the answer to that is yes. So let's check both of them. Is it divisible by 2? Check. Is it divisible by 3? Check. So now we know that the whole number, 246, is divisible by 6. Having a hard time writing today. Divisible by both 2 and 3. So it is divisible by 6. So it's a two-stage test. Test for 2, and if it passes, test for 3. So let's take a look at this one. 236,253. So let's test for 2. Is it an even number? Well, to check for an even number, is the last digit 0, 2, 4, 6, or 8? The answer to that is no. So the test for 2 is a fail. It failed. So the answer to this, right off the bat, you don't have to check for 3. We know it's not divisible by 6. So you can say it is odd, so it is not divisible evenly by 6. Okay, I'm going to give you a second to try this one. 235,222. Why don't you pause the recording and test this one? Okay, so now you're done. The first thing you had to do was check whether it's divisible by 2, and since it ends with a 2, it is even, so therefore the 2 is a pass. Now let's check whether the number is divisible by 3. Well, 2 plus 3 plus 5 plus 2 plus 2 plus 2. You should be able to do this in your head, but I'm sure some of you picked up your calculator. 2 and 3 is 5, 10, 12, 14, 16. So we have a sum of 16. Is 16 divisible by 3 evenly? And the answer to that is no. It's not divisible evenly by 3, so the number is not divisible by 6. All right. Let's turn our page. What I've got here is a Venn diagram. The circle on the left is the divisibility test for 2. The circle on the right is the divisibility test for 3. The ones which overlap are those numbers that are divisible both by 2 and by 3. So that would make this part right here the test for divisibility by 6. So let's take a look at whether or not these numbers are. So let's take a test. 12. Is 12 divisible by 2? Yes, it is. So it's going to be in this circle right here. Let's check and see if 12 is also divisible by 3. And 12 divided by 3 is 4, so this is a yes. That means that 12 has got to be overlapped by both the divide by 2 and the divide by 3. And that makes it divisible by 6. Let's take a look at 21. Is 21 divisible by 2? The answer to that is no. So that means it cannot enter into this one right here. But it is divisible by 3. 21 divided by 3 is 7. So that means that 21 has to be in this circle, but it cannot be in the middle. 42. 42 is an even number because it ends in 2. So you know it could possibly go in the left circle. Let's check for 3. Well, 4 plus 2 is 6, and 6 is the same as 2 times 3, so 42 is going to be in the middle. 56. I want you now to continue, actually, and have you test and place the last 1, 2, 3, 4, 5, 6 numbers, please. So pause the recording and then continue. Okay, so now you're back. Here is your answers. The ones that are only divisible by 2 are 88, 56, and 728. The numbers that are only divisible by 3 are 135 and 453. And the ones that are which are divisible by both 2 and 3 are 12, 42, and 246. If I was marking this on a test or a quiz, you would probably end up having 3 marks, 1 for each grouping. So this would be a mark. If you had them all correct, you get a mark. And of course, you got a mark for that and a mark for that. So you can see that you have to test very carefully. Now the next one we're going to do is the divisibility rule for 9. Now the divisibility rule for 9, you can see it if you look at the multiples of 9. Let's have you take and copy out the first 10 multiples of 9. So 9 times 1, 9 times 2, 9 times 3. And I want you to continue. And you can put 99 if you wanted. Those are the multiples of 9. Now, except for the first one, every number here, in this group right here, has a very unique sum. I want you to add up the digits of 1 and 8, 2 and 7, 3 and 6, etc., all the way through. You should see that 1 and 8 is 9, 2 and 7 is 9, 3 and 6 is 9. So all the numbers have to sum to be 9 for the first 10 numbers. But as you go further, you'll see that the 9 plus 9 is actually equal to 18. And 18 is a multiple of 9. It's 9 times 2. Or if you wanted to, you would say that 1 plus 8 is equal to 9. So really what happens here is that if you can work it all the way down and get a 9, then you're going to have a multiple of 9. So they have to be a multiple of 9. So let's take a check at one of the examples here. So the example I want you to try. Oh, sorry, I want you to try something else here first. I want you to check 99, 108. And these are the next digit numbers that you would see after you had passed and continued on. So you could see that 108, 117, 126, you'll see that they all add up to be multiples of 9. Okay? So I want you to take a look at that. This is 18, this is 9, 9, and 9. So the divisibility rule for 9 is the following. Add the digits. If the sum is a multiple or is divisible evenly by 9, the original number is 2. Okay, so it's very similar to the divisibility rule for 3. You add up the digits and find out whether or not the sum is divisible by 9. If it is, then the whole number is. So going to the next page, I want you to pause the recording. I want you to check these 3 digits and find out whether or not they are divisible evenly by 9. So pause the recording and do them, please. Okay, you're back. Well, 1 plus 2 plus 5 plus 2 plus 6 plus 5. If you add those all up, you get a sum which is 21. Is 21 divisible by 9 evenly, or is it in the 9 times tables? Well, you skip count by 9. You go 9, 18, 27. You skip 21, so the answer to this is no. And why? Its sum is, well, I shouldn't say its sum. No, the sum of its digits is not divisible by 9. There you go. Your decision, yes or no, and your reason. 265,320. So let's add them up. 2 plus 6 plus 5 plus 3 plus 2 plus 0. You can add those up. You're going to find the sum is 18. So this is yes. Why? The sum of its digits is divisible by 9. Okay, the next one. We have 11,304. So I've got 1 plus 1 plus 3 plus 0 plus 4. You add those all up, you're going to get 9. And since 9 times 1 is 9, we know it's in it is divisible by 9 evenly. It goes in one time. So your answer to that is yes. And the reason is the sum of its digits is divisible by 9. Okay, I have one problem for this one that I want you to do. Bob has 24 people who are on his soccer team. That's including Bob. He wants to make drills up in a way that nobody is left out. How many different groups can he make up so that the number in each group is the same, but there's nobody left out? Well, I'm going to help you with the first one. We can make groups of 1. That means that everybody would have a soccer ball and they're all doing a drill by themselves. And in this way, there's nobody left out. What about groups of 2? Try that one. And I want you to go down until you tell me, or until you get to the number until you fill out all the numbers. So pause the recording and find out how many groups can be made up. Okay, you should be done. So what we're really doing here is we're testing the divisibility rules. Is 24 divisible by 1 evenly? Yes, it is. So the groups of 1 would work. Groups of 2, is 24 divisible by 2 evenly? Yes, there's 12 groups. So 12 separate groups of 2 would make 24. What about 3? Well, 24 divided by 3 is 8. So groups of 3 would work. There's nothing left over. What about 4? 24 divided by 4 is 6. So you would have groups of 4. You'd have 6 groups of 4. What about 5? Well, 24 is not divisible by 5. If you remember, the divisibility rule for 5 was, is the last digit a 5 or a 0? Since it's not, it's a 4, that means that you cannot have groups of 5. If you did, you'd have 4 groups of 5, and you'd have 4 people who couldn't make a group of 5. Groups of 6, well, you'd have 4 groups of 6. Groups of 7, well, if you put them in groups of 7, you could make 3 groups of 7, but you'd have 3 people left over. So 7's out. 8, well, 8 is possible. You'd have 3 groups of 8. 9, well, if you had 2 groups of 9, that would be 18, but you'd have 6 left over, so you can't have groups of 9. What about groups of 10? Well, 10, 20, 30. 24 is not a multiple of 10, so you could have 2 groups of 10, but there'd be 4 people left out. What about 11? 11, 22, no, it's out. And now you're probably going to realize that 13, 14, 15, 16, 17, all the way to 24 is, 12. I forgot 12. You can have 12. 2 groups of 12 would work. But after that, nothing else works until you get to 1 group of 24. So there's your answer. Your assignment, it's on the bottom here. Ignore page 15, I think it is. I want you to do this page right there. Okay, stop the recording and get busy. Thank you.